In 1946, a scientist accidentally created a nuclear reaction using nothing but a screwdriver. The experiment lasted only seconds, but the radiation he absorbed would kill him in just 9 days. The object responsible was a small plutonium sphere used in secret atomic experiments. After 2 deadly accidents involving this same object, scientists gave it a chilling nickname, the Demon Core. At the end of World War II, scientists in the United States were racing to develop nuclear weapons. At a remote research facility run by Los Alamos Laboratory, physicists studied plutonium cores that could power atomic bombs. One particular sphere of plutonium weighed about 6.2 kilograms. It was carefully designed for a nuclear weapon, but it would never be used in combat. The plutonium sphere had a dangerous property. If enough neutrons bounced back into it, the atoms could begin splitting faster and faster in a chain reaction. Scientists called this point criticality. If the reaction went too far, the core could briefly become supercritical, releasing an intense burst of neutron radiation. Researchers performed experiments to measure exactly how close the core could safely get. In August of 1945, physicist Harry Daghlian was performing one of these criticality experiments. His goal was to surround the plutonium core with blocks made of tungsten carbide. These blocks reflected neutrons back toward the core. By slowly stacking the blocks around the sphere, he could carefully measure how the neutron activity increased as the system approached criticality. Late one evening, Daghlian was working alone in the laboratory. As he placed another tungsten carbide brick onto the growing stack, something went wrong. The brick slipped from his hand and fell directly onto the structure. Instantly, the core became supercritical. A flash of blue light filled the room as a powerful burst of radiation was released. Realizing what had happened, Daghlian quickly knocked the bricks away with his bare hands to stop the reaction. The radiation stopped almost immediately, but the damage had already been done. In those few seconds, he had absorbed a massive and deadly dose of radiation. At first, he only felt a burning sensation in his hand, but the effects would soon become much worse. Over the next several days, Daghlian developed severe symptoms of radiation poisoning. His body struggled to repair the damage caused by the intense neutron exposure. Doctors at the laboratory tried to treat him, but at the time there was little understanding of how to treat such extreme radiation exposure. After 25 days of suffering, Daghlian died from his injuries. Despite the accident, the plutonium core itself remained intact. It continued to be used for experiments because scientists still needed to understand the limits of nuclear criticality. Less than a year later, another experiment was scheduled using the same core. This time, a different scientist would demonstrate the test in front of several colleagues. The scientist leading the demonstration was Louis Slotin, an experienced physicist known for performing extremely precise criticality experiments. Slotin had done the procedure many times before. The experiment involved placing 2 beryllium hemispheres around the plutonium core. These shells reflected neutrons back into the sphere, pushing it dangerously close to criticality. To keep the hemispheres from fully closing, Slotin used a simple flathead screwdriver. By carefully holding the shells slightly apart, he could control how close the system came to becoming critical. Other scientists watched the demonstration as Slotin balanced the screwdriver between the 2 metal halves, maintaining just a small gap between them. But during the experiment, the screwdriver slipped. The hemispheres instantly closed around the plutonium core. The room was suddenly filled with a bright blue flash, caused by intense radiation interacting with the air. Everyone present immediately realized something had gone terribly wrong. For a brief moment, the core had gone supercritical. Slotin reacted instantly. He quickly lifted the top hemisphere away, stopping the reaction before it could continue. His quick action likely saved the lives of the other scientists in the room. However, Slotin himself had been standing directly over the core and had absorbed a massive dose of neutron radiation. Within hours, Slotin began experiencing severe symptoms of radiation sickness. Doctors documented his condition as it rapidly worsened. His organs began to fail as the radiation damage spread through his body. Just 9 days after the accident, Louis Slotin died from the exposure. After 2 fatal accidents involving the same plutonium sphere, scientists began referring to it with a grim nickname, the Demon Core. The accidents shocked the scientific community and highlighted the extreme dangers of hands-on nuclear experiments. The Demon Core was eventually melted down and recycled into other nuclear materials. But its story remains one of the most chilling examples of how dangerous early nuclear experiments could be. 2 scientists lost their lives in accidents that lasted only seconds. Today, the story of the Demon Core is still told in physics classes and documentaries. It reminds scientists that even small mistakes can have enormous consequences when working with nuclear materials. A single slip of a screwdriver turned an experiment into a deadly lesson that the world would never forget.